We're going to go ahead and get started. I'm Jack Sullivan from Red Carbon. Hi, everybody. Thanks for coming. Welcome to the BECCS Biochar mini deep dive on the Masterminds channel within Air Miners. This is our first mini deep dive into different technical areas important to air mining. What is biochar technically? What makes it hard? What makes it compelling? Strengths, weaknesses. We hope to cover all of these during our session today. We'll try to wade away from policy and instead focus on technology, operating models, ways either can improve to achieve more scale rapidly. First, some general parameters, the initial 30 minutes. We're going to hear from our two speakers. Afterward, I'll conduct a Q&A and randomly call on folks and unmute you, and you'll have a chance to ask your question and maybe one follow-up. Just please keep it brief. Now for introductions to our speakers. We're lucky to have with us two men who are experts in the BECCS and biochar fields. Dr. Wilson Hago, the founder and CEO of his namesake, Hago Energetics, a Carbon X Prize semifinalist. And also with us today, Rick Wilson, an experienced executive leader working in soil health, biotech, ag tech, and currently food safety as a non-executive chairman at PureFresh. We're truly privileged to have them both here today. Rick, please take us off, and the floor is yours.
So Jack, I just want to be clear. We want to talk about biochar and commercialization. That's what you'd like me to sort of give you the views of. Is that right?
Yeah, as broadly as you want to take that.
Okay, so you know, a little bit about my background. I've been scaling up technology since I was a kid. I'm a PhD chemical engineer. I started out in Amoco, which was Standard Oil of Indiana, acquired by BP, where I ran their pilot plants to create clean fuel, which is to reduce sulfur. I also serve on the technical review panel for the National Renewable Energy Lab in the area of Bioenergy. I've actually done that for almost 10 years now, which is pretty cool because I get to really see what the leading edge thoughts are in terms of biotechnology. And, you know, the short answer to that is the lab sees the future of the world being there's plenty of CO2 and electrons are virtually free. So you have to think about how do you make a technology out of those two that's economic. And that's a long-term research program, but they're really working on some pretty cool stuff. I mean, Wilson and I sort of jumped into the biochar world. Geez, what was that, Wilson, around 2012?
Yes.
Where, you know, there was this company, Cool Planet, and Cool Planet developed the ability to take biomass and convert it into a gasoline blend stock using conventional refining technology mostly, and then produce a side stream of this material that we all know now as biochar. And you know, when I joined it, I was supposed to manage strategic relationships coming from the oil sector. They realized I was an engineer also, so they put me to the task of coming up with the economics of doing that. And the first time we ran the economics, all of a sudden I was very unpopular, and people really got nasty at me. So I ran and hid. I ran and hid. And there was one person that was working on biochar. I said, hey, let me see what I can do with biochar. So I pretty much surrounded myself with people that had expertise that weren't mine. I mean, Wilson joined because he was an expert in physical chemistry, and he's also an expert in IP. Wilson's probably filed and got more patents than anybody I know, and he's been pretty successful at it too. So so we sort of dove into the world of biochar, and we really, you know, fortunately we had the fire hose of money from Google Ventures and GE at the time, back when they had money, and we really got to learn a lot about, you know, how this material works and where it works and where it doesn't, and when it doesn't.
I'll jump in. I guess his dog crashed the party.
No, well, yeah, the cleaning ladies came in.
Cleaning lady, well, welcome back, Rick.
So I think, you know, when we jumped into this, you know, biochar can promote growth, and I think that really the discovery that we had was the aha moment to me years later was that really what we discovered was that soils everywhere are pretty degraded, and that, you know, it's almost like the truth of the matter is, you know, in a degraded soil, you can almost put in anything and you're going to get a positive response. And the thing about so you know, I started thinking biochar was the greatest thing in the world, and it was the miracle grow, and it was a secret from the Amazon. And what I really realized was that, you know, it had multiple properties that chances were one of those properties would address a deficiency in soil that could help plant growth. Um, and you know, so let me give you an example. So I'm going to sort of discount biochar on you here. You know, so the early studies with biochar were done in, you know, tropical rainforests, where you take this material, you know, the way you can make biochar is you heat it with a lack of oxygen, you heat your biomass, you get these vapors. In the case of Cool Planet, we converted it as a fuel, and now you have this material. So this material tends to be very alkaline. So it's a base. And it turns out that rainforest soils, and plus at the same time, a lot of times it has not only hard carbon, but it has soft carbon. So think like compost is soft carbon. So it has a mixture of hard and soft carbon. It's very high in pH. So when you put it into these tropical rainforest soils, you saw, wow, look at these plants, they're growing tremendously. This is the magic of the Amazon. And you know, the Indians figured this out 2,000 years ago. Wow, we should run with this. But, you know, if in the cold light of day, you know, fast forward 5 years, what I realized is, you know, in that case, you know, you can achieve what biochar can achieve by adding lime, for instance, right? Or adding compost. So you really have to start to think about when you know, the challenge you have with biochar is that, you know, it costs you money to make it. And, you know, I think the experience that, you know, sort of give you the short thumb there of Cool Planet, you know, they spent a lot of money. You know, they started the market material, and then pretty much the venture capitalists no longer listened to Wilson and I, and they fired us both, and they brought in a professional ag guy, and the company essentially failed. And it failed because biochar was too expensive, right? So, you know, they were trying to sell their biochar for $600 a cubic yard. And when you're trying to sell something into the ag industry at that level, when, you know, they're not willing to pay $10 for compost, it never works, right? And the problem you have in farming is that, you know, 3 out of 5 years, they don't make any money. So farmers are extremely price sensitive to things, and it just never took off. And it's unfortunate. So, because there is a way that biochar can come back to play. So let me sort of give you another view of biochar. So whenever I look at a biochar trial, I ask myself, how else could I have done this? And why did it really work? And the biochar world tries to make biochar sound like this, so it's a special thing, that it's so different than everything else, and they lose everybody when they do that. You know, and what I've done is I've sort of forced myself to learn soil sciences. Every time I see something, I say, okay, what, forget all these fancy properties. Let's reduce it down to what would a soil scientist. So in the case pH, look at pH. You know, does it solve a pH problem? Or, you know, biochar is very porous. So does the soil have a porosity problem so that water won't flow through it? So that's another reason why biochar could work, because you're putting this porous medium and you've got a porosity problem, and all of a sudden water can move in and out of it. But, you know, so if you really look at so what you have to do is you really have to look at a biochar, and you have to look at a soil, say, what's the constraint in the soil, and can this particular biochar address that need and address that limitation? I think that's real. And unfortunately, you know, everyone talks about biochar. They never talk about the soil, and they don't talk about what did that biochar specifically do to that soil to help promote growth. And then ask themselves the question, you know, is that really the lowest cost way of doing that? Or could I add lime? Or is there a lower cost per porous material I could add to it? So, but I think when you roll that up, if you lived in a world where biochar was very inexpensive, I think it definitely has some unique properties. And probably the most unique property of biochar is that it tends to catalyze the agglomeration of carbon in the soil. So if you put biochar in the soil and you wait 5 or 6 years, what you're going to notice is that when you come back 5 or 6 years, there's actually a lot more soil organic matter, which is carbon and oxygen, than what you put in originally versus not having done anything. And that's sort of a combination effect of the plant. Remember, what plants do is they actually synthesize low organic weight molecules and push them through the roots into the soil, and they're doing that to feed the microbes. So if you can stabilize that carbon, which is what biochar can do, you can actually, instead of some of that organic matter being consumed by the microbes, it actually starts to build organic matter in the soil, and actually over time is going to improve the property of soil. I mean, I think that's sort of the magical property of the stuff. But when you put biochar in a pot, and if you see a growth benefit, that's obviously not happening in the time frame over which you do that. So I think that's a unique property of biochar. The other unique property of the biochar is it tends to facilitate nitrogen cycling and the retaining of nitrogen in the soil. So what I mean by that is, one thing that can happen is nitrogen in the atmosphere gets fixed and gets put into the soil and converts to a nitrate through ammonia. So what a biochar can do, or some biochars at least, they can stabilize that ammonia. So what happens during the nitrogen cycle is the ammonia actually vaporizes and never stays in the soil. I think that's another unique benefit of biochar, that it can stabilize the ammonia cycle. So that's sort of really where I've come out with it. It helps, if you have a soil that has a porosity problem, an infiltration problem, it can help you there. It can help you retain nitrogen, and it can stabilize your organic matter if you need to do those things, right? So it's not a miracle grow. It really depends on where you're at. So
From a, real quick, just to prompt another couple minutes, and then we'll hand it off to Wilson. But from a standpoint of sequestration, talk about it from that angle rather than from an ag angle, right? Because I mean, the channel we're on is air miners, and these guys are pretty focused on sequestering carbon at scale. I've heard both favorable and unfavorable aspects of biochar in that regard. One thing I like about biochar is that we're sequestering carbon rather than CO2, so it's a smaller molecule and potentially less stuff to sequester. So just talk about that, talk about the sequestration potential. I've heard albedo is an issue and some other things. Just give me another couple minutes and then we'll let you off the hook.
So, my view of this is that the first thing you have to realize about biochar is you're taking this material and you're turning it into a form of graphite and you're burying it into the soil. So that is an act of sequestration right there. But the problem with that is it's, sort of one-time deal and over. It's really when in a planted system where it's going to facilitate the accumulation of carbon over time. I think that's really where the value is. But remember, it's not just putting it in the soil, it's putting the soil in a planted system that's continuously planted is how you can have a benefit. So that's my view on its value. And I actually think, I wouldn't be surprised if the state of California, once we now have a very broken budget here. We used to pay for things like, there was a big grant solicitation I got really involved with where they actually paid people to put compost in the soil and would actually pay for biochar. That's all gone because now California is broke again. But, if you brought that back, I think the CDFA's asked for some possible best practices around biochar, and there's 3 of them, and I actually put in proposals for them. But I think, the real problem with biochar is that it's expensive, right? And until you fix the cost problem, it's just never going to happen. And I think there's a real opportunity to fix that. If you go out in a forest and chop down a tree, it's going to cost you money. And I personally never felt comfortable with thinking that chopping down a tree is actually going to help you from your carbon balance. It just doesn't feel right to me. But I think where biochar can fit in California, and I think it's actually going to happen, is that in California, there's regulations that are pushing all the green waste out of landfills. And in California, that's a lot. That's more than half of what goes in a landfill in California is green waste. And one thing that you can do with it is compost it. I have 3 consulting contracts where people are asking me to help them figure out what to do with all this green waste. And the waste management companies are paying that. And they're also now paying for biochar trials, where we're finding that biochar can accelerate the composting process. Now, the great thing about, so I think the future world here is you're going to compost some of that green waste, but some of that could be turned into biochar also. And the thing about this, remember, that's a tipping fee based business. So if you had an alliance with a waste management company, you could actually get paid to take that green waste and process it and make biochar. So instead of trying to make money selling the biochar at a high price, you make your money by the tipping fees, by the tax collection fees to make the biochar. So I think that's the future of the world here. And I think, my view is that's how biochar is going to come to fruition, really based on those tipping fees and the regulations. Remember, the reason you're taking that green waste out of landfill is because those landfills are anaerobic and they produce methane, and methane is a potent greenhouse gas. So you want to take that material out and do something productive with it. And so
you're getting a double benefit. You're reducing the biomass extraction or excretion or whatever you want to call it, respiration of methane. At the same time, you're sequestering the carbon by
so at the same time
and improving the soil.
You can, and I'm in the process of proving this. You can speed up the composting process, which allows the operator to capture more tipping fees over a shorter period of time. And number 3, once that biochar is in the soil, it's in a planted system, it's going to accelerate the accumulation of carbon. I think that's where the value level is.
And you get paid to manage the waste. That's awesome.
Yep.
Okay. Thank you, Rick. I appreciate your comments. I'm going to hand it over to Wilson real quick. Wilson, the floor is yours.
Hey, guys. So I'm looking at this I'm going to be looking at it from a different perspective, more of a high level perspective, and also from the perspective of climate change and how we can use biochar as a tool for climate change. And along the lines, I'm going to be talking a little bit about bioenergy. So the reason I'm in this field is because I believe that biochar can have an influence on carbon sequestration, or can be used as a tool for carbon sequestration in addressing climate change, because we need basically at this point all the tools that we can get in order to deal with this gigantic problem. So that's kind of my interest. And then I wanted to ask the audience to kind of make a little bit interactive.
You want me to unmute everybody?
No, well, or we just, people can put in their answers on the chat box, and that'll be. So my first question for everybody is, on a scale of 0 to 10, how solvable is climate change? Is the climate change problem? 0 being not solvable at all, and 10 being completely solvable. Can we have input from people? 0, okay. We have 9, okay. 8, 7, 6 is 8. Okay, so we have a fairly positive group in here. Okay, my next question is, what is your favorite way to combat climate change? Let's see. Do we have? Can people type in their answers? Or
yeah, we're all thinking.
Okay.
I'll buy everybody a little more time. For me, it's 2 pronged. It's about speed and scale.
Right, job at that going forward. Okay. All right. So we have a variety of problems. So okay, renewable energy plus that. Yeah, that's my favorite one. What my thinking on this is that basically biochar should be used as a tool, and biochar should be as free as possible, so that there's basically no impediment for removing the carbon dioxide in the atmosphere to and turning it into carbon in the soil. And that's what my background is based on that idea, that implementing that idea. So as Rick mentioned, I mean, I got my start at Cool Planet. I actually, Rick used to be my boss there, and so I gave him a hard time all the time. Yeah, but we're both biomass guys, and that's we still consider ourselves the kind of proponents of biomass, even though some of the things I'm going to be saying are going to be run counter to the traditional BECCS point of view. So for people who are not familiar, biomass is anything that has lignocellulose in it. It also has hemicellulose, and what happens is that it can include stuff such as algae, biosolids, municipal solid waste. But mostly when people talk about biomass, they talk about trees and the kind of the carbon that's embedded in the trees. And biomass can be burned, and then that's what that energy can be used for make electricity, or it can be fermented, for example, from ethanol, and then and that process gives out a lot of carbon dioxide. So bioenergy itself, if you look at the distribution of bioenergy in the world, there are only a few. There are actually about 3,800 biomass plants in the world. Whereas in terms of natural gas, there are about 10,000 natural gas plants in the world. Biomass, in terms of the energy proportion for biomass, it only comprises about 2% of the mix in the energy mix. And then you have to ask yourself, why is that? Why hasn't biomass been more promulgated in the world? And the reason is that, well, it's not competitive enough in relation to solar and wind as it stands today. So today, the biomass power plants can't make anything, sell their electricity for cheaper than 4 cents a kilowatt hour, whereas solar and wind can go into that. Although when you start including distribution charges, then things become more even. Now, if you want,
I'm sorry, you said 4 cents?
4 cents, yeah.
4 cents.
Yeah, and so the only people who are making money in this field are people who are engaged in PPAs, the power purchase agreements, where for example, in California, where your business, your electricity production is tied in and then it's locked in for an extended period of time, at about 19 cents or 20 cents a kilowatt hour. So that's what the reason most power plants can't stay in business is because of this PPAs. And if you want to add carbon capture and sequestration on top of that, it becomes a tougher proposition, because those units, the CCS units, add a substantial cost to the present order of business. There are numbers flying around there. What I see mostly is like $100 a ton for the capture units, depending on what exactly you're doing. If you're doing a gasification, there are estimates that the CCS component is going to be less. But at the end of the day, I mean, you're paying. If you want to run a BECCS plant, you have the BE component, which doesn't make you very much money, and you add on top of that a CCS component, which is also not going to make you money, except if you have government incentives. Now, the government incentives at the present moment is that you can get $35 a ton for CO2 captured. So what that does to you is to throw you into the barely profitable category, and then so it's a hard haul for BECCS kind of to get going, especially if you want to implement it as a global solution or as a tool for addressing climate change. And it can be part of the tool, except that you have to then think about all these other consequences. Okay, on a global scale, if I do want to have BECCS as a tool in addressing climate change, what do I need to do? And one of the things that I think it needs to be done is basically instead of just having the electricity do component, make some carbon in your BECCS process. And that what allows you to do, instead of having just being able, your carbon being worth just a few dollars for the electricity, what you're able to do is then have carbon that you can sell for a few $100s a ton. So that makes your value proposition that much more valuable. But in the end, as I mentioned, ultimately, if you want to address the climate problem, you have to make a biochar as cheap as possible, and you may have to, the government ultimately may have to pay people to take it and put it in the soil, and so that they can just use it just because it's not only will it help the soil, but it helps the planet in terms of carbon sequestration. So there are the problems with BECCS. I mean, I'm sure people are well familiar. I mean, it takes a lot of land to make biomass, there's also the problem of the life cycle analysis. There's some, I may call it cheating in the biomass industry in terms of carbon accounting. If you just have a tree lying down there and it's decomposing, it's actually carbon positive. And if you put it in your biomass plant and then you burn it right away, all the carbon dioxide goes into the atmosphere. So whether you use fossil fuels or whether you use biomass, I mean, carbon dioxide is carbon dioxide. It's going to affect the planet in the same way. So you have to be careful in terms of the carbon accounting. You implement CCS, you make the bioenergy process, all of that carbon neutral essentially, right? So if you want to truly make it carbon negative, then you have to make some sort of sequestrable carbon, such as biochar, and then so that you can drive the process negative. And then that's kind of an important consideration going forward. I mean, you shouldn't try to fool nature. You shouldn't try to fool yourself by believing that the biomass is this BECCS approach is a carbon negative approach. The important consideration in all of this is that you have to do everything. You have to first of all replace the trees. So tree planting has to be an important component of this. Ideally, you want to be able to grow the trees as fast as you're taking them in the bioenergy process, as fast as you're consuming them. I mean, the kinetics don't work that way, but ideally that's what you really want to do in order to keep the accounting correct and to do the implementation of BECCS as an approach to climate change. So I think with that, I think that's what I want to end. And I mean, there are other approaches. Let me just say, BECCS is just one approach. There are probably anywhere from 10 to 50 approaches that we should be doing simultaneously going forward in order to address climate change. And each of these approaches can knock off 1 or 2 gigatons, and that's perfectly doable. And I believe that BECCS is a technique that can be done at the 1 to 2 gigaton scales and have an impact in the grand scheme of things.
Very good. Thank you, Wilson. I appreciate your comments. Thank you as well, Rick. Now the fun part. I'm going to unmute everybody because there's not that many folks. So hold your voice for the moment. And then if you have a question, raise your hand and I'll just call people randomly and unmute you. Actually, I'm going to unmute everybody. Let me do that. And then, yeah, raise your hands and I will call on you. Yeah, bear with me. I'm working through everybody. Unmute, 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 unmute. Thought I could unmute everybody all at once. I guess not. Okay. Brett. I'm sorry, I wasn't looking at people raising their hands. Who wants to go first? Kent, fire away.
Cool. Thank you, Wilson, for joining this, and thanks, Jack, for putting this on. You keyed in on one of the key questions always of cost. So I guess, Rick, you touched on it. You said initially this has been like $600 a ton, I think is what you said. I was just curious, where do the costs stack up currently? And then, how do you envision driving those costs down? I know you talked about tipping fees, and that's kind of a business model solution to help maybe drive the costs down, but just wanted to get your guys' thoughts on that. For biochar, I should have been specific to that.
I think that I think the fees, you know, you have to realize that tipping fees would pay for the capital costs of a biochar machine. So, you know, I'm busy trying to make that happen, because I think and I think the way you get people to make that investment, the people that will make that investment probably the compost operators, because if they'll make the investment so that they can speed up the process. That's their leverage with this. But the other thing you can do, you know, the problem you have with any biomass-based system is lack of economies of scale. So, you know, the whole concept is, from a capital cost perspective, you always want to make it bigger. So if you start with this size and you double the size, the capital cost only goes up 50%. So you want to do that all day long, which is why you have oil refineries, right? But the other way to do that is the economies of mass production, right? Think of Henry Ford. So I think there's a real possibility, modular, where these things come pre-assembled and you put them in the field. I think that's a way that you could bring biochar capital costs down, actually, and bring that. But I think the first step is really to leverage the benefit it has, and I hope that I prove that it has, and it's working well pretty far, that we can accelerate the compost process. And then, you know, there's a reason to build these things.
It can't, let me address that. Yeah, we're taking the approach is that, biochar it's kind of a relatively new industry. It's going to take some time to get it into the market. Our idea is that you have to basically subsidize it. And then the way in our process, the Hago Energetics process, we make multiple products, and then basically the other products subsidize the biochar. And ultimately that will drive the price down.
I mean, Wilson, the model I'm working on is biochar for free.
Yeah, exactly. So we both agree on that.
So when you buy compost, you get the biochar in it, and you're using it and you don't even know it, right?
Yeah.
So then the incentives can be used to incentivize farmers and help your financial model. I mean, incentives at that point are gravy. That's interesting.
Right, absolutely.
Kent, do you have a follow-up?
Well, you touched on the end with all this talk about, you know, the political campaigns, and I know the Democrats and Biden have talked about trying to get the farmers involved on climate change and mitigating that. Seems like this is a natural lead into that for farmers. That's really it. That was just kind of the sentiment. So be curious of other people's thoughts and questions.
All right, who's next? Raise your hands. I'll go. I have a technical question. Can you go through the technical process of creating biochar? Now, I've already learned something. I'm not a biochar guy. I think, Rick, you mentioned that biochar effectively takes a biomass and turns it into roughly the density of graphite. So talk to me a little bit about the process. Is it just heat? Is there pressure involved? What's the energy cost? You also talked about the idea of mass producing modular machines, which is really interesting. I'm trying to evaluate from a timing and scale standpoint what can be done rapidly. And the idea of mass producing modular machines is very interesting to me.
So, I mean, you know, very simply, you know, you make biochar in your gas grill, right? So essentially you ground up biomass and you heat it in the absence of oxygen, right? So you don't want it to burn. And essentially what you end up with is as a biovapor, which has BTU value, and you end up with this carbon material. So actually biochar is usually very light and fluffy, but the carbon in it, I mean, literally when you look at under a microscope, a scanning electron, you actually see the structure of the underlying wood, but the carbon's been, you know, biomass is carbon and oxygen. The oxygen has been removed, so it's really a very dense carbon material, and that's why it's stable. That's why it's stable in the soil. So that's how you make it. I mean, from an energy perspective, you know, the challenge you have is you have to heat it up, and typically what you'll need to have some external source of heating to get this thing going. But then what you can do is you can take those vapors and combust them. And once this process gets going, you can self-sustain the energy requirements just by combusting the biovapors that come off of the biomass. That's how, I mean, Wilson's trying to make multiple products out of those streams, which is a whole nother play. and capture some value add there. But, it's just biochar alone, I think, could be energy self-sufficient once you get it going, but you're going to need some natural gas or propane to get the thing off and running.
Wilson?
Right. So yeah. So you have to do a pyrolysis on the biomass, and then you have to remove the carbon and the oxygen, and then the process in itself, decomposing those molecules, creates a porosity within the biomass itself, ultimately, which gives you the porosity for the biochar. So you're talking about 100 to 200 meters square per gram at that point.
Say it again. 100
to 200 meters square per gram in porosity. And that's enough to provide the necessary porosity for the microbes to go in and help the plant to reach temperature.
Why did it make so much?
Excuse me, was that a question? Somebody asking a question?
I don't know what that was. I think we had a guest.
Okay.
This is a very interactive presentation. My follow-up is just to probe a little further on the density. One of my business models for red carbon is to figure out a way to 3D print carbon composite blocks. But the way I can miniaturize those blocks is to compress within the 3D printable material enough carbon so that it's as dense as possible. That way the blocks aren't so big that I have to handle a lot of volume. So if I can handle a 2-foot on edge block, I'd rather do that rather than a 10-foot on edge block. The key component is the density of the carbon. So if I burn wood in my fireplace, the density of carbon is relatively low. But if I look at like a tennis racket and graphite, the density of carbon is relatively high, and the difference could be like 10x. So I guess what I'm trying to get at, and I don't know the answer to the question, how dense can you get biochar just through the current manufacturing techniques to then spread it out on the acres that you want to spread it on? Is it a dense carbon, or is it still relatively porous?
I'm pretty sure I understand your question. I mean, you can biochar after it's made is very friable, which means that you can break it up easily. So you can adjust the bulk density easily. After you make the biochar, the density can be as low as 0.10 grams per cc. So that's pretty light. And then as you break it up and you can compress it, then you can bring it up to 0.5, 0.6. So
when you do that, you just grind it?
Grind it, yes. It's very, very grindable. You can make ultra fine powder out of it.
So you turn it into a powder, and you can achieve that by grinding, and you can get to about 0.6?
Yes. Yes.
Okay. No, that's very helpful and good to know. If I wanted to get it a little denser than that, how do I get there? I have to apply more heat, or?
Yeah, I don't think you could do that unless Rick, you can think of something. But yeah.
That's a really good question. I mean, I don't think anyone's looking at that, but I mean, that's ripe for innovation, right? And
Yeah, just an interesting question. That's all.
But yeah, I mean, that's another interesting play on this. I mean, there's people that are making asphalt out of biochar, or there's a bunch of other value add things going on. I mean, but it has to be backed by a commercial model, or it's never going to happen. That's the challenge.
Understood. Who else has a question? Shannon, you're up. Let me unmute you.
On mute.
Yeah, I'm asking her to unmute.
Right here. Okay. Yeah, can you talk a little bit about the what makes the capital cost so high, and so just go into that a little bit, either Rick or Wilson.
Well, I think so Wilson has his own flow scheme, and he can speak to that, but in general, the capital costs are high because not a lot of people are doing it, right? So every machine sort of a one-off, first time, so you haven't climbed down the cost curve. I think that's a big part of the problem. And the other one is, you can only make these things so big because, you have to feed them with biomass, and the bigger they get, the further you have to go to get the biomass, and the more you're going to spend to get the biomass to the central site. So, I think that in California, the model that I'm hoping to advance is, there's sort of all these locations where there's this stranded waste biomass, and the number turns out to be about 100 tons a day. So, I think that's really, so you really need to make the economics fit on that. And, my thought on economics and business models in general, the first, I actually think that given the capital costs that we can get the waste management companies to invest in these things. But, for any new technology, I think the first goal is you at least want it to make money on a variable cost basis, and that, over time the capital costs can come down. But if you can't build your first plant and have it at least generate a little bit of cash, you're never going to get to the second one.
You have a follow-up, Shannon?
Yeah, Wilson, the stuff that you're working on, is that sort of like a gasification type lead?
Yeah. So the basics of the CO2 conversion is basically a thermochemical conversion of CO2, where you react the CO2 with biochar, and then to convert that to carbon monoxide at high temperatures, and it's gasification process, right? And then you combine the CO with hydrogen from methane decomposition, and then you make liquid fuels that way.
Very good. Anybody else have a question? Christian, you are up.
So, Wilson and Rick, thanks for the presentation. That was very informative. I don't have that much of a background in soil or agriculture or anything, but I've been noticing that there's new technologies where you can spread like sand on top of the soil. And so I was wondering if there was any talk about formulating certain soil, like a compost that you put over your field, but it has like some of the sand in it, some of this biochar in it, and kind of like this soil or carbon sequestering soil that has all of these different components in it that kind of, I don't know if they would compound on each other or build on each other if you had some minerals also within the soil, but what are your thoughts on combining like mineralization and biochar? Is that a possibility?
Yeah, there've been experiments of kind of people mixing in the biochar with this rock dust, and they've noted synergistic effects. So definitely that makes perfectly good sense. I mean, you add more minerals in with the rock dust, and then you have a biochar as the water and nutrient retention device. So it makes good sense. I mean, basically double use soil amendment.
So Wilson, I can tell you, I'm pretty involved in that. One of my roles is I support a company, Agromin, which is the largest marketer of compost, and they use me. So they'll get orders for soil or specialty blends of material, and they'll blend 50 semis of it, and typically what that looks like is compost and sand. So what you're trying to do is a specification for a perfect soil, and and soil, sand, silt, clay, but there's an optimal amount of sand, and needs organic matter, it needs porosity, and we've done blends where biochar and minerals will fit into that, and it turns out, it's all about price, right? So we actually have a linear program where we put in the price of different things, and we say, this is what the spec needs to be, and hit the button, and it tells you which combination to choose. There's sort of two markets for that. One is that anybody that wants topsoil, the Class A topsoil in the U.S., nobody in California, nobody wants to volunteer for me to bring a tractor in and scrape up your Class A topsoil. So that's number one. There's a market. There's another big market for the cannabis industry that does this at scale, and these guys love biochar. They love it because of it, the way it facilitates nitrogen cycling. So they get more nitrogen into their soil, and that gives them a better outcome for plants. So I think, Kristen, you're right. That's a great idea. It's already happening. But I don't know that anyone's yet wanted to take a farm and repurpose the soil. I haven't seen that. But what I have seen is these custom blends done at a very large scale.
Okay, awesome. That's good to know. I'll have to look into that more. Thank you.
Wilson, anything to add or ready for another question?
Let's go on another question. I mean, it makes perfectly good sense. So yeah, I mean, just go for it and start selling some soil amendment. The world needs it.
Who else has a question? Otherwise, I'm going to throw out some harder ones.
Oh boy.
Anybody else got one? Brett, you just sponging right now?
I think Jack,
That's
if you
fun,
start a
Jake.
hard one, you'll motivate other people to do likewise.
Kent, you wanted to jump in, so go ahead, and then I'll hit them harder.
Okay. Okay. Just to follow up on that question, I'm thinking about like the farmers in the Midwest. So dialing in from Chicago and grew up from an ag background. What does, like, did you guys get down the path to what the application would look like to a farmer that, grows soybeans, corn, wheat, and how they'd actually have to apply that to their field, how this would work? I'd be curious what that looks like.
Well, Wilson and I are actually on a number of patents where we've that have been filed in Cool Planet's name in terms of what the application methods are. I mean, it really depends on, what you're trying to do. In general, given that biochar is so expensive, you're probably not going to treat the entire soil, but you might treat the planting zone, right where the seed is planted or right around the root zone. I mean, at least given the cost of biochar as they are today, that's pretty much what you're limited to do, I'd say. But, once the cost goes down, and I think it will, I think that can change. It can be, just a compost spreader that just drops compost between rows of an orchard, for instance, or drops their biochar. It's really a cost issue for the biochar.
Yeah, and I guess to that point, do you have to actually like drill it in, like using like a drill or an anhydrous application, or is that the thought?
Yeah, that's one of the ways to do it, depending on what you're trying to do, right? A seed drill. Right?
Yep. Okay.
Yeah,
Very good.
and to do that at the time you're putting the seeds in. Yep.
Great. That makes the most sense. Is basically you plant the biochar at the time that you're doing the planting. And the other thing that we used to work, we kind of had the philosophy is that basically we don't want to change agricultural practices, so we just piggyback on what the farmers were doing and just add a biochar on top of whatever it is that they're doing in terms of irrigation. We don't want to change their irrigation schedules, or we don't want to change the fertilizer application. We just combine biochar with whatever practices that they normally do.
Got it. Makes sense.
Question for you both real quick. Actually, Rohit, jump in. Please, let me unmute you.
Okay, thank you. So it's a question for Jack, Wilson, and Rick, perhaps all together. And just Rick, I should say that in about 10, 12 years ago, I think you came to Singapore, and I used to sit next to a guy called Matt Sullivan, who said, I have just met the most interesting guy that I've ever met from Cool Planet. And he tried to get us all excited. I was a BP at the time. So I think I remember your name from days gone by, if that rings any bells. No bells. Okay, never mind. You probably met a lot of people. So I was saying to Wilson on another chat the other day, so we are looking to effectively reshape the anaerobic digestion industry, and that requires a bunch of biotech at the front end, so we can process lignin-rich materials like wood, cereal straw, energy crop, stuff like this. So there's a front-end solution. We're also thinking about biochar for digestate as well, and I think digestate in Europe tends not to be very well managed, and it's a headache for a lot of people. So I think there's a lot of potential there. And at the top end, and exactly as Wilson was saying, it feels like, if you remember all the President's Men, when they're in the car park, when you ask somebody in the AD industry, what do they do with CO2? They say, meet me in the car park at midnight and I'll tell you. And it's sort of Hal Holbrook saying, we just vented, don't ask us that question again. And so we're also thinking, if we're trying to create the AD plant of the future, what do we do with the CO2? So we were thinking in the context of a circular economy piece, okay, does it make sense to take that CO2, turn it into algae of some description, and then either put the algae back in the digester or if you can sort of slightly high grade it, and recognizing that we're doing this at a relatively small scale, could you turn that into animal feed? So when you think about, the CO2 cycle, if I could call it that, do you think that algae is something that has lots of potential and we haven't sort of arrived at that point? Or do you think that it's just doesn't work at a small scale, it's too complicated, doesn't work in sort of low light areas?
So aqua, leveraging the 70% of the earth instead of hitting up the smaller parts.
So Wilson, Rick, any thoughts on algae as a CO2 sink?
It makes perfectly good sense. I mean, that's what nature does, right? In terms of sinking CO2. The question ultimately is what happens after the algae has consumed that. Does the carbon just go right back, or does it ultimately? What is the fate of that algae?
Well, it's around replacement. I think a lot of the work in sort of that we're thinking about is it's actually sort of backing out some, a worse solution. And this is maybe the kind of debate that we're having on the Slack group and other Slack groups is it's not, for me, it's not necessarily straight jump to hydrogen, but actually making the world cleaner relative to what it does today. So if you can secure point sources of CO2, okay, you might not be able to sort of completely consume that in, say, side a tomato farm or soft drinks or whatever else, but can you turn it into something which then either allows the bio industry to grow therefore at the expense of the fossil fuel industry, or in the context of, say, producing animal feed, can you give it to cows, and cows are producing less methane? So that's the kind of thing I'm thinking. But I was just wondering, does algae feature big in people's minds, or it's a still relatively niche story?
So I'll give you my view. I've looked at algae in great depth for water treatment purposes, which is where my interest is mostly. It is an economic question. But the good news is there's been a lot of development, right? And the costs are down. So I think you just have to, it's really going to come down to the techno-economics of what you want to do. I mean, algae, is complex to the extent that it doesn't grow when the sun's not up, right? So, and it goes through, it's a living system, an algae farm, but I think it's, I know NREL has some economic studies out there on algae. So I think, I think it's absolutely a legitimate approach. Does it pencil out? I can't answer that question.
Okay.
I'll throw in just a general comment, not as a biochar expert, but a general comment. I'm pretty focused on negative carbon solutions rather than circular carbon solutions. I like the idea of using carbon in products, but I'm cautious about using carbon in products that aren't non-biodegradable, if you want to use that phrase. So stuff that maybe gets recycled and then gets back in the atmosphere, right? If it's not sequestrable, I'm probably focused elsewhere. That's just my 2 cents, but I'm not a big circular carbon guy. I'm more of a negative carbon guy, but that's just me.
Yeah, no, absolutely. I think exactly as Wilson said, all these results, all these solutions need to add together. And for us in that 10 megawatt equivalent AD plant of the future, all the digestate at the bottom goes to biochar. And we started speaking to some guys in Singapore who are producing biochar pellets, and they seem to be coming to market. And it feels like, okay, there's a there's a solution at the front end which stops natural emissions in a sense, because you're taking in cheap feedstocks, etc. Again, backs out natural gas, etc. And then there's a CO2 solution of some form, and then there's a biochar solution. So I'm trying to think that all of that allows that bioeconomy to double in size, and that at some point, especially in places like Asia, where if they don't need it, they'll just burn it. And I'm trying to avoid all of that taking place.
Rohit, thank you for dialing in.
Okay,
Thank you for your question. Anybody else have a question?
Well, I just want to add that, I was looking into algae as kind of as a feedstock to our process. And then I went down to Ensenada, talked to the guy who ran the Ensenada kelp, and then asked him about the possibility kind of growing algae on a big scale. And he seemed to be kind of doubtful about it, just because he said from a nutrient point of view, algae are very finicky. what the nutrients that they need, and they have to be at the right temperature. And then so he said it, don't go that route.
Okay, that's useful. Thank you very much. Thanks. Okay, I'll let you get back on.
That leads into my final question. We'll call it the final question, and then we'll wrap. Scale. I'm scared is maybe the wrong word, but I'm challenged by understanding how to scale biochar rapidly. There's one thing about scale and leveraging Earth systems, which over time makes sense because they're massive systems. But given the amount of speed that's now part of our answer, I struggle with the idea of leveraging agriculture or leveraging farms or leveraging acreage to grow something rapidly, given that we're up against the clock now. So even you mentioned, Wilson, planting trees and reforestation and that kind of thing. The trees are getting younger, right? So even today, the amount of soil that's being sequestered by our forests is diminishing already. So as the planet warms, and it takes us a while to figure this out, every day that goes by, the forests are getting less efficient at sinking carbon because the trees are getting younger. So even if we replant what we take away, we're cutting down an old tree and we're planting a young tree. We're decreasing the carbon sink. So I struggle with that, and that's my tougher question for biochar. If you guys want to just address it generally. Otherwise, I think this has been great. Please.
So I have a strong view on this, actually, and I think the real opportunity that everybody misses is everybody wants to displace the oil industry. They want to shut those refineries down. That is completely the wrong approach. The way you need to be thinking about it is, how do we evolve the existing refineries into the bio world? Because, you know, one of the things that you have, you know, when you build any plant, you have this thing called ISBL, inside battery limits, and you have OSBL, all the things and utilities that take. If you co-locate whatever you're doing at a refinery, you get rid of a third of your costs right there, and you're plugged into supply chains. So you really have to think about where, you know, you can't do this at every refinery, but you could do a bio refinery in Louisiana, right? There's lots of oil refineries there, and there's lots of woods there. So I think that's the way to think about it. And anybody that takes that path is going to win. But so far, nobody's, and Wilson and I never spoke about it. I have very specific ideas, you know, about, you know, so integrate your pyrolysis plant for biochar at a refinery. Why not, right? These guys want to, you know, I work for an oil company too. We're all not bad guys. And, you know, everybody points the finger at the oil companies saying we're bad. I'm like, well, how did you get here? Right? You're the problem. You're the creating demand for the product. We're just here to help, right? So, but I think that's a way to think about this that really could win for everybody. But nobody seems to be thinking that way.
Thank you, Rick. Wilson?
Yeah, so we need to jumpstart the biochar industry. I mean, it's still, it's not at the scale that it should be. And I think the one approach is just go with the tipping fees. Right now, there are 140 million dead trees in California just because of a past drought. And then those trees, we should prevent them from just going up in smoke with the next fire. So let's turn those trees to biochar. And I mean, there are tipping fees. The farmer there will pay you to take the trees away, and then you can use that as a kind of to make the biochar for, and then you can make it somewhat a decent profit at the end of the day. And also, but one proviso is that you really should take advantage of the 45Q credits and then sequester the CO2 that's from the pyrolysis process after you burn the pyrolysis gases. Otherwise, you're not helping the planet.
Very good. Gentlemen, ladies, do you guys have any more questions? Rohit, you're raising your hand. Keep it brief. Hold on, let me unmute you. Please, Rohit.
No, I was just saying thank you very much, Jack. You put a lot of comments on the DAC chat, so please keep them coming, because I think it takes a lot of people are very motivated to make an impact, but they probably see solutions as being relatively simple and quick, if I can sort of generalize, coming maybe from a software or a different type of digital world. Whereas, yourself, Wilson and Rick have lived technology development for many years, it sounds like. So thank you very much for sort of sharing your insights with people.
Rohit, real quick, where are you calling in from?
Well, I'm a Brit, but I'm sort of in lockdown in India at the moment. So
You're in India, so we're getting a call in from India. So you win the distance reward.
Okay.
Very good. Rick Wilson, Wilson Hago, all the attendees, thank you for coming. I'm going to go ahead and wrap it here. And again, yeah, I learned some stuff. I hope you guys did. Have a great afternoon.
Thank you, guys. Thank you. Take care.